guys, so today we're doing the second half of 813, which is now we're doing comparing the volume and surface area of similar solids. So let's fill out some notes. If two solids are similar with a scale factor of A to B, then their volume and surface area ratios are as follows. Its area, so remember area is squared, so this is A squared to B squared. And remember, volume is cubed. So this is A to the third to B to the third. Now let's work an example. Okay, we're going to kind of treat this as, so we have to identify the scale factor, the surface area ratio, and the volume ratio for each. Now remember, we set this up as the scale factor of A to B. So we're going to go through here and I'm going to kind of draw a little line down here so that we understand this will say is figure A. These are figure B when I'm working these problems. Okay, so let's jump to number 2 when we're doing this. So scale factors, that means I'm going to take one of the linear sides and set it up. So I'm going to have 45 over 27. If I divide by 9, then that's going to give me 5 over 3, which is the ratio 5 to 3. So that gives me my scale factor. Now, when I'm figuring out the surface area ratio, that means I take this scale factor and I'm now squaring it. So I'm going to do 5 squared over 3 squared to figure out the surface area, which is going to give me 25 to 9. And then for the volume, that's where I'm going to do 5 cubed over 3 cubed, which is 125 to 27. And moving right along, we're now going to look at number 6. Shuffle around my pages here. Make sure we can see everything. Okay. So for this, we're finding the surface area. So we're going to use A squared to B squared, which means I'm doing the scale factor squared. Okay, so we have cylinder A is similar to cylinder B, and it has a scale factor of 2 to 5. And the surface area of cylinder B is 375. We want to find the surface area of cylinder A. Well, remember, surface area is squared, so that means I've got a scale factor of 2/5. So therefore, I'm going to do 2/5 squared, which is going to give me 4 over 25. And now when I have similar figures, you can't see that too well because of the glare. I'll have to remember that. I got to figure out how to fix those lights. Okay. So now we have our proportion. Because it's similar figures, the sides are proportional, so I can set up a proportion. 4 over 25 equals x over 375. And now we solve our proportion, which is going to be 25x equals, I'm trying to figure out how to make this work right there so we can see it. 25x equals 4 times 375, which is 1500. And then we divide by 25. And if we don't know that, I'm over here doing 375 times 4, 0, carry my 2, 28. So that's 30. So 4 times 3 is 12. Plus 3 is 1500. And now I need to divide by 25. Well, 25 is going to go into 150 for 6 times and then add a 0. So therefore, we end up with x equals 60 meters squared. And that is cylinder A. Next example. Let's look at 8. The surface area of a prism is, so we have surface area is 700. If its dimensions are doubled, find the surface area of the new prism. So we're looking for the new prism's surface area. So if it's doubled, then that means my scale factor is 2. So remember, when it's surface area, that means we do the scale factor squared. So that means it's going to be 1 to 4. This is actually not 2, it's 1 to 2, because I'm figuring out, I'm making a proportion, so I have to have a ratio. So therefore, I'm going to have 1 over 4 equals 700 over x, because I'm doing the old over the new here, because I'm doing the 700 over, because the original over the new, which isn't always the way it's, but you could set up your proportions differently and still end it up correctly. You could do 4 over 1 equals x over 700 and still get the same information, because we now multiply diagonally and we get that x equals 2800, and my units are centimeters squared. Next example. Number 9. This will be our last one. This is where we're finding the volume. So remember, for volume, it is scale factor cubed. So this is a cubed to b cubed. So if solid A is similar to solid B, and the scale factor is 4 to 3, the volume of solid A is 704. We want to find the volume of solid B. So I'm going to have my scale factor, which is 4/3. Well, the scale factor cubed is going to be 4 cubed over 3 cubed, which is going to give me 64 over 27. If you don't know that, then you're going to multiply it out. That's 4 times 4 times 4, 3 times 3 times 3. So this is the ratio I'm going to use, because I'm now talking about volumes. So I'm going to have 64 over 27. It's 4 to 3. So this is A to B. So therefore, we're looking for the solid for B. So this is going to be 704 over x equals, now we solve our proportion. So I have 64x equals, now I got to come over here and I've got to do 704 times 27, 8, 2, so it's 2, 9, 4. Put my 0, 2 times 4 is 8, 2 times 0 is 0, 2 times 7 is 14, add 8, 0, 1, 0, 1, 9, 1. So we end up with 19,008. Now we divide by 64. So that means I'm going to come over here and do that division. So I have 64 into 19,008. So 64 to 190, that's 2. 2 times 4 is 8. 2 times 6 is 12. So this is going to become 10. It's going to become an 8. 2, 6. Bring down this 0. So 64 into 620. So 6 into 64. So we're going to try 9, because I can't do 10. So 9 times 64, 9 times 4 is 36. Carried my 3. 9 times 6 is 54. Plus 3 is 57. Subtract. That's 10. This becomes a 1. So this is 4. 7. So this becomes a 5. So this is 11. 4. Bring down the 8. 6 into 44 is 7. 7 times 4 is 8. Carried my 2. 7 times 6 is 42. Plus 2 is exactly 44. That worked out nicely. So we have that x equals 297. Where's my units? kilometers cubed. Okay, make sure you pause as needed. Have a great day.